Well, hello Internet, and welcome to the continuation of my data science and machine learning tutorial, and more specifically my Plotly tutorial. In this one video, you're going to learn how to plot numerous things with Plotly, and it's going to specifically allow you to create over 40 beautiful interactive is the main part here, web-based visualizations that can be displayed in Jupyter notebooks or saved to HTML files, and it is widely used to plot scientific, statistical, and financial data, and it's free unless you want them to host the data for you, which in this video we will not do. And I have a lot to do, so let's get into it. Alright, so if you are using Anaconda like me, you don't have to, and I'm going to show you what to do here. Basically go to your environment tab and you can pick whatever environment you want, type in Plotly, select Plotly, and then come down here and click on Apply. That's going to install Plotly. Then what you need to do is come in and install cufflinks. So if you open up either your command line if you're on Windows or your terminal if you are on Linux or Mac and type in conda install conda-forge cufflinks-py. That is going to install all that stuff. And you're also going to see that you're going to install Chart Studio, which is very important, and a whole bunch of other different things, but you have to click on or type in Y to proceed to install that way. Or what you can do is you can use pip to install this stuff, and you could just type in pip install Plotly, and then pip install cufflinks, like that, into your terminal or your command line, or whatever you would like to use. Alright, so we are going to be importing a whole bunch of different things, and you probably should be aware of pandas and NumPy and a whole bunch of other different frameworks, which I have tutorials for all of the above. So we're just going to be installing everything we need here to make our charts in here all work. And here is what I mentioned before, Chart Studio and Plotly as py. Then I'm also going to bring in Seaborn because I'm going to be stealing some custom-made data sets that Seaborn provides. Of course, you're going to have to install all these things. If you want more information, just look in the description. I have links to everything that I'm typing in here. Going to be using Plotly Express. And if you want everything to show up directly in Jupyter notebooks, type in matplotlib inline. Another thing, if you want to make Plotly work in your Jupyter notebook, you're going to have to say from Plotly offline import download plotly.js and init notebook mode plot iplot, and I'm going to be covering all these guys. And then you're going to have to type in init notebook mode connected equal to true. And then the final thing you need to do here to make everything work locally, type in cf.go offline. And I got an error, just throw that up there, and everything is wonderful. All right, so I got everything imported. Now I'm going to cover the very basics. Whoops, I also need to import cufflinks as cf, and it looks like everything is working now. All right, so now I'm going to talk about the basics. Now I'm going to present information in numerous different ways so that hopefully you'll be able to use any type of data here to plot these different plots. Alright, so the very first thing, I'm going to create a NumPy array, and it is just going to have random values, and they're going to be 50 values with 4 columns in them. Then after that, I'm going to define a data frame, and this is pandas, data frame, and I'm going to use my array data that I went and generated. And then I'm going to define what the column names are. So I'm just going to make this very simple, A, B, C, and D. And we can come in here and take a look at this data frame with head that just shows us the first 5 pieces, and it's all just random data. Now what I want to do is I want to compare the old plots that I have used previously. So data frame 1.plot, and you can see that plot right there. That's the old way of doing it. And I'm going to show you multiple different ways to do this with Plotly, but right now I'm just going to use iPlot. And you're going to see how much nicer and clearer and much better the plots are in Plotly. And you're going to be able to come in and see it's very, very interactive, all the data. You're going to be able to come in and take a photo, save it as a ping. You're going to be able to zoom. You're going to be able to pan. You're going to be able to zoom in, zoom out. You're going to be able to auto scale. You can change the axes. You can do so much stuff with Plotly that you could not previously do. And this is just the beginning. Now I'm going to dive deeper into line plots. Okay, so I'm going to do another import here. Plotly and graph objects as go. We're going to be using this a lot. And this is going to allow us to create graph objects for making more customized plots. So what I want to do here first is I'm going to get a data frame that is going to have Google price data, and then I'm going to use it to make a couple different plots. So px data stocks, and this is information that's built, or a data set built into Plotly. And you can see a whole bunch of them right here, Plotly data package. And there's a whole bunch of different things here you can play around with just to get used to Plotly, and I'm going to be using them myself. So there you go. All right. So what are we going to do with this data that we have here? If you just typed in plotly.data package, you're going to be able to find that online, but you don't really need to because I'm going to describe a lot of it. Okay, so what I want to do here is just go and print a line chart that's going to have all kinds of information on price changes with Google stock. All right, and this is based off of the X axis is going to be based off the date, and the Y is going to be based off of Google price data. And then I can apply labels for customization here. And let's say that I want the X axis to be labeled as date, and I want the Y to be labeled as price. I can do all of that, and then just make sure that's has a closing parenthesis. Hit Control and return, and you can see how nice that chart is. All right, and all that information is all plotted out, and also it's extremely interactive, which is fantastic. Now you also can make multiple different line plots. I'm going to go px.line and df stocks. That's the data frame I'm working with. And again, I'm going to use X is going to be the changing dates. And then after that, Y, if I want to have multiple different plots inside of it, what I just do is throw everything inside of a list. So I'm going to have Google inside of there, and I'm also going to have Apple inside of there, and that's the stock name for it. And I can have special labels. So I'm going to say that I want labels is equal to, and then I have to define what I want the X label to be. And I specifically want that to be date. And then I want the Y label to be price. And then after that, if I want to put a special title on my chart, I just say title is equal to, and I'll call this Apple versus Google. All right, and we can see which is doing better. And there is our plot, and you can see Apple is doing slightly better than Google on the stock market. All right, let's do a couple more here. Now you're also going to be able to do really complex types of graphs using figure. So to do that, you just say go and figure like that. And what I want to do here is I want to pull individual columns of data from the data set and then use markers, which are going to be set for different prices and such. And how you do that is you go figure dot add trace, and I want this to be a scatter plot. So I'm going to go scatter, and then I define my X position by referring to my data frame and specifically the date, and that's the X-axis, and the Y-axis. Again, I'm going to be using my data frame, and I'm going to be plotting information on Apple. And what else do I want to do? I'm going to say that I want my mode to just be lines, and that I want to name this so that it updates in the legend, which automatically is generated, to Apple. All right, and there'll be colors associated, of course, and so forth. All right, I want to add another one. Let's say I want to add Amazon this time. Well, I just changed this to Amazon, like that. And I'm going to change this to Amazon, of course. And this time I want to not only have lines, but I also want markers, little dots, wherever all the spaces are. And you're going to be able to change the different dash types as well, which I'll show you whenever I plot Google next. All right, so this is going to be Google, which is just, that's their ticker symbol. And I'll change this to Google like that. And the mode, I'm just going to let this be lines and markers again, except after I have Google here, what I'm going to do is I'm going to do some special line styling. And to do that, you do line and you create a dictionary. I can define the color that I specifically want. So let's say I choose Firebrick, and I'll get into where you can find the colors and so forth later on. And let's say I want a custom width for this line. And let's say that I want a custom dashed line. So let's say I want dashes and then dots. That's how you do that. And you can also just come in here and instead of dash dot, you could also just type in dash or just simply dot. Okay. And if we run that, you can see how those have all changed here and how they line up and how the dash dot look with our stock chart looks. You're also going to be able to further style the figure. And how you do that is with Fig and Update Layout like this. And what I'm going to do for this is I'm going to say that I want to add a title to this. So I'm going to call this Stock Price Data 2018 to 2020. And what else do I want to do? Let's say that I want to change my x-axis title to be equal to price, and I want to change my y-axis title to be equal to date. I can do that. And you can see how that changed and how we changed the naming on the axes and so forth. I'm going to block this out though, because I'm going to show you how to change even more. All right, so let's go completely crazy with styling this. I'm going to go Fig and Update Layout. And I'm going to go and define the axes very specifically. And from now on, very often, you're going to be able to use these same exact stylings with all the other different plots, for the most part anyway. So what I'm going to do here is I'm going to say that for the axes, do I want to show the lines? The answer to that is going to be true. Am I going to want to show the grid? Well, let's change that to false. Do I want to show my tick marks? So tick, or this will be the labels, equal to, I'm going to say true. What else am I going to do here? Let's say I want to define custom coloring, and this is just on the x-axis what I'm making changes to. And you can use custom colors by name, or you can come in and do RGBs, and you can also do hex codes. So pretty much anything you could ever want to do, you're going to be able to do. Let's say I want to change the line width on the axes. That's what I'm working with here. There's line width. I can define if I want my ticks to be on the outside or the inside. And I can also come in and define my tick font with a dictionary again. So I'm going to say dictionary like this. And then I'm going to say that I want the family to be equal to, you can use a whole host of different fonts, and I'm going to have the size be equal to 12, and I'm going to have the color be equal to RGB, and let's make this 82, 82, 82, like this. Then after this, I'm going to go and do similar stuff with my y-axis. So I'm going to say y-axis is equal to, and again, we're going to be using a dictionary. Let's say I want to turn off everything on this, just to do that so you can see the difference between doing everything and basically doing nothing. So I'm going to say 0 line is equal to false. I am going to do show line. That's also going to be false. And I'm going to go down to the next line. On show tick labels, I'm also going to have that be false. So you're going to see basically everything, and then you're going to see nothing, just to be different. And let's go and throw this onto my next line, like this. And I can also have it set up. There's auto size. That's normally on by default. I'm going to turn it off. And you can also define your margins. And this is going to be dictionary. And what am I going to do with it? I'm going to do auto expand. I'm going to turn that to false. I'm going to define then the left, right tops. So left is equal to, you can do whatever you want here. So this is left. This is going to be right. This is going to be top. And then the final thing I'm going to do here is I'm going to say show legend. And like I said, you're going to be able to do this. These are all grid changes, and these are grid changes you're going to be able to make on a lot of your other different plots, all the same default things. So, and then let's say I want to change my background color to be equal to white. All right, so geez, oh man, that's just about everything you could ever imagine doing. And of course I got an error because there's always something when you type that much code in. And normally when you get an error, you want to scroll to the bottom of the screen. You can see right here, it tells me I'm missing a comma. All right, so let's go like that. It's actually a good thing that happened. And there is our new plot that we just made based off of all those numerous different changes. All right, so I think you got a good grasp on how to do numerous different line plots and how to change the defaults and mess around with the grid. Now I want to talk about bar charts. All right, so everybody knows what a bar chart is. What I'm going to do here first is I'm going to get population changes in the United States, and there is a provided Plotly data set that has this type of information in it, and it's called Gapminder is the name of the data set. And you can query your data as well if you want to get specific types of data. So let's say that I only want data if the country column is going to be equal to the United States. That's how you do it. So I'm only going to get US data. Then I want to create a bar chart. So I'm going to say df US data frame. That's what anytime you see the df, you know that's a data frame. And I specifically want my x-axis to be the year, and I want my y-axis to be equal to the population of the US. And I should have typed in px. There we go. And you can see how the United States population has changed from 1950 to 2000 and something or other. All right, and it's 2007's the data that they have. All right, let's do another one. Let's say I'd like to create a stacked bar. So this time I'm going to use another data set that's provided. I covered this in my Seaborn tutorial. It's exactly the same data. This is tip data. So what I'm going to do is I'm going to use the tip data that's provided by Plotly, and I'm going to make bar, and this is going to be data frame tips, and I want the information on the x-axis to be based off of the day of the tip, and then I'm going to have the y be based on the tip amount. I'm going to have the color that's going to be associated with the sex of the payer. I am going to give this a custom title, which is going to be tips by sex. And oh, by the way, this Jupyter Notebook, I'm going to put it on GitHub so you can get the whole thing. So for free, of course. Tips by sex on each day. And anything else I want to do? Yeah, let's throw some custom labels on this as well. So let's have, and again, you just go labels is equal to, and a lot of times if it's done one way with one plot, it's done that way with all the rest. Now, if I want to change the label, and the label's currently set for tip, well, I put its current name inside of there, and then I put the new name that I want associated with it. So that's how you replace different labels. Day of the week, like that, and run it. Tips by sex on each day, and you can see how those line up, and they're all stacked, and you can see we can roll over it and get all kinds of information. So really neat stuff. But you may say, well, what if I want to place my bars next to each other? Well, you can type in px, and let's go and get X and Y and color like this. I'm just going to copy this and throw it in here and just change it a little bit. So let's have X be the sex, and let's have Y be the total bill, and let's have the color be based off of if the person smokes or not, which I don't know of a single restaurant where you can smoke, but whatever. And then if you want them stacked, you have to go bar mode, and then group like this, and run it, and now you have bars that are next to each other. So the sexes are, or the smokers and non-smokers are going to be divided up, all right, and as well as the sexes. All right, so more ways of doing bar charts. Let's go and do another one. Let's say I'd like to display a population data for countries in Europe in 2007 greater than 2 million people. So I'm going to get a data frame just to show you another different way to stack queries. And I'm going to say px.data.gapminder and issue a query. And that query is going to be that the continent is going to be equal to Europe. Make sure you keep your quotes different. So the outer quotes have to be different from the inner quotes. And the year has to be equal to 2007. And let's go and throw another one in there. The population has to be greater than 2.e to the 6, so 2 million. All right, so there is querying that information, which is something we haven't been able to do previously. And now we can go and make a bar chart. So I'm going to say df Europe, that's my data frame, and then I have to define what my y is going to be, and I'm going to make that be population, and I'm going to have the x be equal to the country, and I'm going to have my text that pops up be equal to population, and I'm going to have the changing colors be based off of changing country information, and run it. Did it work? Oh, I know what I did. I have to come in here now and type in figure underneath of it for it to show up, and fig like that. And there you can see all of those different countries with, if you can see here, if I zoom in, that's the number of people that live in those countries. I'm going to show you near the end of this tutorial how to animate all this so you can change it. So you'd be able to go and find different population changes depending upon different years based off of scrolling through data, which is really great. All right, let's go and do, let's say we want to do some other things though. I am going to put the bar, the population total above the bar. So, because I think that looks a little bit better. It's kind of hard to see. As you could see, I had to go and type inside of there. And how you're going to do that again is by updating your figure. So I'm going to say update traces, and I'm going to say text template is equal to, and with this guy, what I'm going to do is I'm going to say that I want the text inside of here to be, let's say, like 2 in size. So we're only going to show, like, if it's 82 million people, it's only going to show 82, for example, or something like that. And I'm also going to put the text position to be outside of the bar instead of inside of it, which is the default. I'm also going to come in here and I'm going to set my font sizes. So I'm going to say update and layout and uniform min size equal to 8. And then finally, I'm going to take these labels that are down here and rotate them 45 degrees. So I'm going to say figure and update layout and I'm going to do axis, or let's do x-axis. X-axis tick angle equal to and negative 45 degrees. And here is my error. It says uniform min size. I want this to be uniform text min size. And I run it. And now you can see that it's easier to see the population is 82 million and everything. And you can also see this is angled and so forth and so on. All right. So there's a whole bunch of different ways of creating bar charts. I'm actually going to show you some more here in a couple minutes. But now I want to talk about scatter plots. All right. So hopefully you know what a scatter plot is. I'm guessing that you probably do. Let's say that I'm going to use the iris data, which is like information about iris flowers, which I don't know anything about, but it looks good with a scatter plot. So it's basically information about different types of irises and their different petal lengths. I don't know, but that's what it is. Okay, so then I'm using an included data frame again, which is also in Seaborn. So what I want to do is I'm going to create a scatter plot. So px scatter, and I'm going to use the iris data frame, of course, and I'm going to have my x. Basically, there's two types of petals on irises, I guess. One's called the sepal, and the other is called the petal, and that's what that is. So there's sepal width, and I am also going to have my y-axis be equal to the sepal length. And I'm going to have the color for the different scatter plots to be equal to species. There's different species of irises. And I'm going to have the size of the dots be equal to the petal length. And whenever you hover over the individual dots, what I want you to be able to do is go and see the petal width. Okay, so just about every type of different thing you can imagine. And this will be petal width, like that, and run it. And there you can see, and you can also see there's a little legend that was automatically generated, and it looks really nice, and it looks really clear. All right, so good stuff. Now let's say that we'd want to create a more customized scatter plot. Well, I'm going to go figure equal to go figure. This is normally what we do whenever we want to add more detail. So I'm going to say figure dot, and then I'm going to add a trace, and specifically this time I'm going to, of course, use a scatter plot, and I am going to define x is equal to, and in this situation you have to say use your data frame. So it's going to be iris, and then you go and use dot notation to be able to grab that specific information. So I want sepal width, and I want y to be equal to, again, data frame and iris, and this is going to be sepal length, like that. And then I'm going to come in and do some styling on my markers. So the markers are the little dots. So markers, and I'm going to say that I want my marker color to be equal to the changing values for the sepal width. So there's that. And I want my text to be equal to the data information that is to species, because I think that makes sense. And I also am going to provide some more information about my markers here inside of a dictionary. And I'm going to use scaling. So make that equal to true. And what else do I want to do? Well, I'm also going to come in here and set my marker line width and my marker size. So I'm going to say figure and update traces. And I'm going to set my marker line width to be equal to 2, and my marker size to be equal to 10, and run it. And you can see that we are able to come in here and style this scatter plot, and it looks pretty cool. And you can see there's a new type of key over here to help you better identify what's going on. And you can see there, setosa is a specific type of iris. And another thing is, let's say you're working with a massive scatter plot. Well, if you're working with a lot of data, you should use something that's called scatter GL. And so we're going to say go figure, and data is equal to go dot scatter GL. And then I'm going to go and have X values be equal to, and I'm going to generate random, whoops, if I can type random right, random values. So random N, and I'm going to say that I want 100,000 of them. Okay, so pretty big set of data, and I want my Y to be equal to another 100,000. So we can go and grab that as well, and it's going to plot 100,000 points on the screen. And what else? I'm going to do mode equal to markers, and then define some styling for markers. So again, a dictionary here. And I'm going to go and have my colors also be random. So let's go and get each one of these is going to have, each 100,000 is going to have a random color that's going to be 100,000 in length. All right, and what else do I want? I'm going to use a color scale map, color map, and it's just a set of colors. That's all. That's what a color map is. That sort of blend into each other nicely. I'm going to show you here where to find color map information. And let's go and have my line width be equal to 1. And I think that's everything, and run it. And you can see how long it takes to generate 100,000 dots inside of a scatter plot. Actually, no, you can't, because I have to type in fig like this. And you can see there it generated 100,000 different dots. All right, and that took about 4 seconds on my computer, 3 seconds maybe. All right, so there you go, a whole bunch of information on scatter plots. And up next, I'm going to talk about pie charts. All right, so I'm going to do kind of a complicated pie chart here. What it's going to do is it's going to chart out the largest nations in Asia. So I'm going to get a Asia data frame from the included data sets that are provided by Plotly. And I'm going to be using Gapminder. Again, Gapminder has a ton of different data to mine through. It's really fantastic. You should check it out. So I'm specifically going to look at the year 2007. And I'm going, you can stack your queries. Let's say that I want my continents to only be equal to, and this is, remember, keep your quotes different. Let's say I want this only to be Asia, because that works out for me. And then I'm going to create a pie chart here. So I'm going to use my Asia data frame, and I'm going to say that values that I'm going to use inside of it, because there's only one thing with a pie chart. My values in the pie chart are going to be based off of population. I'm going to have my names be equal to, based off of country. Whoops, put quotes around that. All right. And I'm going to give this a title, and it's just going to be population of Asian continent. And I'm going to use another color map thing here. Color discrete sequence is equal to px colors sequential, and this is going to be red and blue. And here is the actual, if you go to plotly.com, Python / built-in color scales, this guy right here, what this is going to do is provide you with all sorts of different coloring you can use. It's going to show you samples of them. So there's Viridis that I've used a bunch of times. There's a whole ton of them. And you'll be able to go in there and get a better idea of what types of colors you want to use with Plotly. All right, so that's where that stuff comes from. So let's run it, and you can see population of numerous different countries inside of Asia, and there is all of our information. So pretty neat stuff. Very interactive as well, which is fantastic. And this is just tip of the iceberg whenever it comes to what you can do interactive-wise using Plotly. All right, so let's customize a brand new pie chart. So what I'm going to do is I'm going to create an array that's going to have a bunch of colors in it. And this is going to be Pokemon information, and it's highly inaccurate. So I'm just typing in basically things. So black. These are Pokemon types and using customized colors and so forth. So sorry, my Pokemon data is not 100% accurate. I am just doing this for fun. All right, so brown. All right, so there's 6 colors, and I'm going to say go fig is equal to go figure. You can have these arrays be outside or inside, and then depending upon what you want to do with it. I'm going to show you both. So I showed you creating the data outside in an array, and now I'm going to show you what it looks like if you generate it inside. So I'm going to go dot pie and labels. You could have this be outside, but I'll do it in. All right, so there's water, and this is grass, and I'm going to say normal type, and psychic, and fire, and ground. All right, so there's different Pokemon types, and then I'm going to assign values to them, and they'll automatically figure out how to make 100% based off of what values I provide. So I'm going to say there's 110 water Pokemon, 90, 80, 80, 70, and 60, and good enough. And we can say fig, and it went and automatically generated that pie chart with all that information. Now let's say that I would like to come in here and stylize this a little bit. See if you can remember what you use to stylize it. It's called update traces. So let's say I want my hover information to be equal to, and I want to show the label plus the percent. There's that. Let's say I want to change my text font size. I can do that as well. And let's go and have text info be equal to, once again, label plus percent. Previous it was just showing percent, which is kind of boring. And let's go and say that I want to pull out the first Pokemon block and in the array and the third. And I'm going to pull them out by different percentages. So how you do that is you say pull, and put this on a separate line, and then you have an array that's for each of the different Pokemon blocks, or each of the pie slices, I guess I should say. So I'm going to pull this out 10%. I'm going to leave the other one where it is, and I'm going to pull out the next one 20%, and then I'm going to leave the rest of them exactly where they are. So that's how you pull out individual slices. And then I'm going to provide some more specifics for marker. I'm going to say that I want the color to be equal to this colors array that I created up here. So there that is. And then I'm going to put some line information. So dictionary. And this is the line that goes around each of the individual pie slices. And I'm going to have the line that goes around it be equal to white. And I'll use hexadecimal codes here just so you can see what they look like. All right, so that's white. And do I want to do anything else? Yeah, why don't I do width for the line and make it equal to 2. That is a lot of Pokemon information. All right, and we run it, and now you can see it's white. You can see that this pulled out and this one pulled out, and the rest are all exactly the same. And you can see how everything was styled there. And you can change the font size to make the ground go back inside of there. All right, so there you go. Pie charts. And now I want to talk about histograms. All right, so now I'm going to cover histograms. So what I'm going to do here is I'm going to have 2 dice that are going to be NumPy random integers, And what I'm going to do is I'm going to generate values from 1 to 7, and I'm going to generate 5,000 of them. That's going to simulate one die being rolled. And then I'm going to do another die, and what we're going to do is we're going to plot out the probability of rolling different values based off of just random dice rolls. And you can think about what's going to happen here. If you think about what the probability of rolling dice is and which number is going to come up the most. All right, so then I'm going to say figure is equal to px and histogram, and dice sum is what we're going to be modeling here, and bins is going to represent how many pieces of data, and I have 11 total dice probabilities with rolling 2 dice, so I'm going to throw 11 in there. Sometimes you might want to change that, make it bigger, make it smaller, but normally you would never want to make it bigger than the number of possibilities, because then you just have empty space. Okay, so I'm going to go and change the label for value, and I'm going to put this on the next line. So it's value by default, so I'm going to change that to dice roll, and that's the way that Plotly always does everything. If you want to change the label, put in the label's name and that pops up on the screen, and then change it to whatever you want it to be. And that's all that I have label-wise. And then I'm going to change the title on this, and it's going to be 5,000 dice roll histogram. And then I'm going to say marginal and violin, just to throw something extra into this guy. And I'm going to change the color on my histogram. This is how you do that. To green, and that's how that's done. And I can just go and run this. Oops, I actually have to throw fig inside of here, then run it. And you can see that it goes and generates a violin plot up here. I'm going to get more into violin plots, but this is the histogram part, okay? And you can see that if you roll dice, 2 dice, 5,000 times, the probability of rolling a 7 is going to be the highest, and it goes down from there, of course. All right, so what else do we want to do? Well, let's say we want to style this a little bit different. So what am I going to do? I'm going to call update layout, and let's say that I want to change my x-axis title text to dice roll. And what else do I want to do? I want to change my y-axis title text to dice sum, and then let's say I want to put like a gap between these lines, these bars, because it sort of looks a little messy. Actually, histograms normally don't put a gap, but I'm going to break that rule and put a little bit of a gap inside of there. And I'm going to say legend doesn't really make sense, so show legend in this situation. I'm going to mark that as false. And now you can see there's a little bit of a split between it. Like I said, normally histograms you don't put a split, but I felt like being a rebel, and that's what I did. And another thing you can do is, let's say you'd like to stack your histograms. So I'm going to go and get my tips information, px, data, and tips. This is tips at a restaurant. And I'm going to create a histogram here using my tips data. And the X is going to be the total bill. And this has to be in quotes. And then I'm going to say that the color is going to be based off of the sex of the customer. Control, and I need to get rid of the fig part. Boink. And there you can see is that information, and you can see that we were able to stack one histogram's worth of data on top of another histogram worth of data, which is really cool. And then, of course, you can come in here and change the axes and all that information. And you can also see now that the legend makes sense, we're going to keep the legend. All right, so cool stuff. And it's just some awesome things you can do with histograms. Now I want to talk about box plots. All right, so a box plot is going to allow you to compare different variables. And the way it works is the box is going to show the quartiles of the data. So I'm going to use my tips again. So df tips is equal to px data tips. And of course you can use this from the other cell that we have here, but what the heck, I just threw it in there. All right, And how you create a box plot is you go px box, and I'm going to be using the tips information, of course, and x is equal to, and this is going to be the sex data, male or female, and then the y-axis is going to be the tip amount, and I am going to also say that I want points to show up next to the box plots, and so to do that you do points and all. And if we plot this out, those are the points I was referring to. That represents all of the tip amounts. And then the box plot right here, basically, like I said, the box is going to show the quartiles of the data. And the bar in the middle is our median. And the whiskers, these are called whiskers right here, are going to extend to all the other data aside from the points that are considered outliers. And the outliers, there are none. Oh, well, yeah, the reason why the outliers aren't showing up is because of the points that I have here. This would be considered outliers, these points right here, and this 1 point right here for females. All right, so good stuff. And let's do some more with box plots. Box plots are actually kind of useful. Okay, so let's say that I would want to display the tip sex data by day. How would I do that? Again, with a box plot, of course. So I'm going to go df and tips, and x-axis is going to be based off of days, and I'm going to have the y-axis be based off of the tip amount, and then the color is going to be based off of sex. And run that, and now you can see that we're able to get this is still going to be the male or the female amount. As you can see, females are blue and the males are red. And you can also see the outliers here because I did not put that I wanted points to show up, and everything is based off of day. All right, yeah, I think you can see how powerful this is. I really like box plots. It's like one of the main plots that I think is fantastic that I don't see that many people use. Okay, so I'm going to say go figure here and do something even more complicated. Basically, what I want to do is add the standard deviation and the mean. So I'm going to say fig add trace. Remember, whenever we're doing multiple different traces or we just want a lot more options, we use add trace with our plots. And again, I'm going to say the x, and this is what's different when you do add trace. You have to go and refer to your data frame, and then using point notation, well, not point notation like that, point notation like this is how you're going to assign your data. And then I'm going to go df again and tips, and this is going to be the tip amount. And let's say that I want my marker color to be equal to blue. You can do that. And let's throw this on the next line so you can actually see it. And blue, and I want to, this is the whole reason why I did this, is I want to show the mean and standard deviation. So I'm going to say box mean is equal to standard deviation. And you can see that it goes and has the median in the straight line, and then you're going to have your mean in the jagged dashed line, and then your standard deviation, which is really cool. And let's do some really complicated styling, like really complicated. So what I want to do here is I'm going to get some stocks data is equal to px and data dot stocks like this, and fig dot go figure. I think that's easy to remember. Whoops, fig is equal to go figure. And I'm going to go and do some add traces, and I'm going to do 2 of them this time, and I'm going to add points, and I'm also going to use jitter, which is going to spread apart the points. And let's see if I can think of anything else to do. So I'm going to go box and y is equal to df stocks, and I'm specifically going to grab Google price data this time, and I'm going to say that I want the box points to show all like that. And what else can we do? I'm going to have the fill color. I'm going to change that as well, and I'm going to change it to blue, and blue like that. And jitter, I want my points to not overlap, and that is what setting jitter to, or using jitter, that's what it does for you. And whisker, I can change the size of my whisker That's the point that comes off with the little T at the top of it and at the bottom also. And let's change that to 0.2. And let's go and add another trace on top of this. And this one is going to be represented with our Apple price data. And what am I going to do here? I can have August points all. Oops, make sure I get rid of that part right there. And let's do like a fill color and red. And everything else there looks perfectly fine. And let's do even more styling. I'm of course going to do update layout, and I'm going to change my title to be equal to Google versus Apple, and I'm going to change my y-axis color. So y-axis is equal to, remember, anytime you do styling like this and update layout, you're going to use a dictionary. And I'm going to do grid color is equal to RGB, and I'm going to make this be white, so all the color. And what else do I want to do? Well, I'm going to change my grid width on this. I think I covered grid width before, and actually grid color, but whatever, I'm just going to do it again. And you can also change the paper. That is the part of the screen that is not part of the plot. So I want to have my paper be the, this is background color is equal to RGB and 243 and 243 and 243. Okay. And then I'm also going to change my plot color. So plot background color is equal to RGB. And let's just make them the same so that they sort of blend together. And I think that's it. I think I did all the styling I wanted to do. And see, now previously the plot was in here and it was a different color than the page. Well, now it's all the same. And you can see all of the different changes. And I can go in there and change the legend by assigning names to these guys, but I'll let you do that. Or add trace right here, just assign a name, and you will see the name there. And there's all that additional information. All right, so I talked about violin plots before, and now I'm going to show you them in detail. All right, so a violin plot is basically a combination of a box plot, but what it does is uses a KDE plot, which is sort of like a smoothing out of the values. And you're going to see what that looks like. So I'm going to go and do my tips data again, and data and tips, and there we go. And I'm going to create a violin plot right now. So I'm going to go px violin. I'm going to use the tips information, obviously. And the y-axis on this is going to be total bill. And I sometimes use double quotes, sometimes I use single quotes. It's a matter of me just wherever my fingers are at the time. It doesn't have anything to do with anything. So use them all. And if I also want to show points next to the violin plot, I put points all like that. And what did I do wrong? Oh, it's data tips like this. Boink. There we are. And that's a violin plot. You saw one before, but it was horizontal. Now this is the way it normally is. And here's the points that show up on top of it. So you can see how cool this is. All right. So that's a violin plot. And let's go and do a more complicated one. You can also show multiple plots at once. So I can say PX and violin and DF and tips and Y is equal to tip. And then I can also give X is equal to, let's say, whoops, forgot to put the double quote inside of there. Double quote right there. And then we'll say we want smoker information in a restaurant. I have no idea what restaurant where they smoke, but I guess this might be old data or something. And the color is going to be based off of the sex of the customer, and box is going to be true. And let's do points. Let's do it all. Let's show the points also. And let's also change what happens whenever you hover over a data point. And let's say that we want to display the columns information. So there's that. And there you can see I was able to plot male and female violin plots with the regular points and all of this information, and whether they were a smoker or not. All right. And I mean, oh, it's so great to visualize data like this. Okay, now what I want to do is I want to set it up so that I morph the left and right sides based off of if the customer smokes or not. So I'm going to have to do something really complicated here. I'm going to have to do, and that normally means I have to use go figure. So go figure, and I'm going to, I'm also probably going to use add trace, because anytime I do anything complicated, I always use add trace. And I'm going to say go and violin, and I'm going to define that the x-axis is going to be df tips, and you see how we're accessing the data in different ways here. I'm using this as sort of like an array, or an index, I mean. And then I'm going to say that I want df tips also, and whether the customer was a smoker or not. And I'm doing like a weird query here. So this is another way of querying data. And what else are we going to do? Well, I'm going to set the y-axis. So df tips again. This is going to be based off of total bill. And also whether the, why don't I just grab this? This is going to be smoker yes again. And we can grab the whole entire line right there. Put it right here. And there we are. And I'm going to do the legend and legend group, and let's do yes. I'm just doing the whole shebang this time. Scale group, and I'm going to have that be yes as well, and I'm going to also have the name show up. And is there anything, whoops, I hate it when nice quotes get out of control. All right, and I want this to be on the left. This is going to be on the left side of the violin plot. So to define that, you say side is equal to negative. That is the left side of the violin plot. And then I'm also going to change the line color to be equal to blue. All right, so there is my first violin plot. And these are actually making, this is the left side, and then I'm going to have the right side of the violin plot. So I'm sort of making the violin plot directly inside of here. So to do this, I'm just going to say no for smoker, and everything else is going to be exactly the same. So you're going to see the smoker and non-smoker information. So this is no, this is going to be no also, and this is going to be everything. Oh, this has to be positive. So positive, and if I, and I also need to change the color on this. I'll change it to red. And if I run it, see, I created the left and the right points in completely different ways. There's my points that I also said that I wanted to keep. And this is the information on the days. And you can see that this is going to be whether they smoke or they don't smoke. And it's just a really interesting way of plotting information. All right, so there you go. There is a whole bunch of different things you can do in regards to violin plots. And now I want to talk about density heat maps. All right, so just to show you how this works, I am now going to use data from Seaborn. And I've shown you how to create custom data inside of it. I showed you how to use built-in data sets inside of Plotly. And now I'm going to show you how to use built-in data sets inside of Seaborn. And if you want to see what this looks like, it's just flight data. So we have the year, we have the month, and the number of passengers, and then it changes every year, okay? So there's all of that. All right, so what are we going to do with it? Well, one thing is you're able to set the bins with these heat maps. I never do it. If you want to, how you set the bins is you go nbin sx or nbin sy. I almost always use the default, and you give it a value. So bin depending upon for the different columns. I just wanted to tell you that even though I never use it. And heat maps are pretty straightforward. What we're going to do is px and density heat map, and this is going to be flights is the data set that we're using here. And I'm going to be using specifically for the x-axis. This is going to be the year data from that data frame and also the month. And I am going to base the actual value of the data frame is going to be based off of the number of passengers. So there is a different type of thing. And I'm going to use I showed you color. Yeah, I did. So I showed you earlier the color maps and all of that information. So I'm going to say scale is equal to, and I'm going to use Veritas because it looks kind of cool. And if I go and create that and say fig and run it, I'll get an error. Okay, so passengers, isn't it passengers? I see. I'm supposed to put flights. All right, run it. And you can see the heat map then. And everything's based off of the number of passengers, the sum of the passengers for each month, and then also for each of the years. And you can see that most people travel in July and August. I don't know if that's still true, but in 1950 something that was true. All right, so there's one. And let's go and also say we wanted to show like a histogram at the tops and the bottoms of this. We can do that. We can say marginal x is equal to and histogram. And then we'll do the same thing for marginal y. So just an added little feature, marginal y is a histogram. Oh, and in this situation, you can't use color continuous scale. Get rid of that. Whoops, get rid of this extra point we have here. And now you can see that it's showing in the histogram. All right, so not much information, but did my best for the different data, and you can play around with different data sets, of course. All right, and so there is a density heat map, and now I want to talk about 3D scatter plots, which are really cool. All right, so wait till you see this. You can create a 3D scatter plot. So I'm going to come in, I'm going to use my flight data again, px and scatter 3D and flights, and this is going to be the year, and it's going to be the month, and it's going to be, now we're starting to get into stuff that is more interactive. So passengers, and then the color is going to be based off of the year. And why don't I go and change the opacity to 70% so that I can see my points through my points. So I'm going to say 0.7 and figure and run it. And you can see here is a 3D scatter plot. I can move it around here. And what we're going to be able to do is sort of turn it. Isn't that neat? Directly right here in Jupyter Notebooks. How cool is this, huh? You can look at your data from numerous different directions. And in a similar way, we can also do something like this with a 3D line. I'm going to actually copy what I created up here, like literally copy the whole thing. And I'll show you a 3D line plot. So throw this inside here, and I'm just going to change this to line 3D, right like that. And everything else, I believe, is exactly the same. Let's just run it. I'm not sure if I can do opacity. Yes, you're not allowed to do opacity. That's what I thought. So let's get rid of opacity and run it. And now you can do a 3D line plot. So really cool, and you can move it around, look at your data from numerous different directions. I mean, just so fantastic. And we're not done. It gets even better. We're going to be able to animate our plots here really soon. And if you stuck around this long, please take a second and tell me in the comments, just so that I know I'm not sitting in my basement talking to myself. So now let's talk about scatter matrices. Okay, so with a scatter matrix, we're going to be able to compare changes whenever we are comparing our column data. So I'm going to say fig is equal to px and scatter matrix. And I'm going to use my flight data again, just because you're probably used to it. And we're going to base our color off of our month and, well, fig, of course. And look at that. Now we're going to be able to put everything in different facets. I'm going to talk more about facets here in a second, where we'll plot multiple different plots all at the same time. So look at all of that information based off of your stock information. Okay, so cool stuff. And I'm going to show you also something really neat. It's called a map scatter plot. All right, and there are numerous interesting ways to work with maps. And in the Jupyter Notebook, I'm going to put a link to the map information that's available to you. Basically, what you're going to be able to do is change colors inside of a map. And let me just show you what it looks like. So to do so, I'm going to say data frame is equal to px, and I'm going to use our Gapminder information because it kind of makes sense to use Gapminder. And this is going to allow me to create like a globe that I'm going to be able to spin around. And I'm going to do a query here. And I'm going to say that I specifically am interested in data from the year of 2007. And then I go fig is equal to px and scatter geo. I'm going to use this data frame right here. And I'm going to say locations is equal to ISO alpha. And wait till you see this globe. It's really cool. I'm going to change colors based off of the continent. And this is just going to be which column to use to set the color markers. That's what that is. I'm going to change the hover name as well to be the name for our country. And I'm going to set, this is going to represent the size of the markers, is going to be represented by the population. And then this is the thing you can change to create all kinds of different maps. I'm just going to show you one. Like I said, in the Jupyter Notebook that I provide for free, I provide a link to all the other ones. I think the orthographic one's kind of neat because it is a great big giant globe you can sort of spin around. And there's other ones that are really cool. All right, so there you go. There's your globe. And you can go to all the different countries and see the populations. Like, this is neat stuff. And you can spin it. So you can see all of the different fantastic countries and all of the populations in said countries, at least for the data that we have here. All right, so cool stuff. And now I'm going to talk about what is called a Choropleth map, which I very rarely use, but I came across this example and I think it's fantastic. All right, so what I did, I actually came across this when I was making this Plotly tutorial. This is like a new thing that I'd never seen, and I just wanted to share it with you. What I'm going to do is, this is the only time I'm going to do this, but I just wanted to show you the code and explain exactly what's going on. So basically, what is going on here is you're going to be able to color really complicated maps like we are going to represent here by showing unemployment data in each of the different parts of the United States. So what we're going to do first is we're going to get URL open, and of course this is going to allow us to grab data from a supplied URL. We're going to import JSON library right here, or module, and it is going to allow us to decode the JSON data we're going to be pulling in. And then with URL open, we're going to this URL, and what we were specifically, I don't know if you can see it here. Like I said, the Jupyter Notebook has everything, and you just copy and paste everything. Basically, what this does is this grabs U.S. county geometry data, and then we're going to be able to change the colors on all the different parts of the U.S. depending upon unemployment rates. And the specific information we're going to be grabbing is the county information. As you can see, we're putting it right here. And then we're going to be, with this guy right here, we're going to be going and getting the raw unemployment numbers. And FIPS is a reference to Federal Information Processing Number. All right, basically what it is it's just a specific number associated with specific counties in the United States. And we're reading that in as a CSV file. And then here is where we're actually creating the whole entire map. And we're going to be drawing the map using county JSON data, and we're going to be coloring the map using unemployment values, and they are going to, there's varieties again for the different coloring, and we're going to be using color range from 0 to 12, and that's basically everything. And there's the unemployment numbers. Now if I run this, and there you can see it went and got all of that information online and populated it and colored it and everything. It takes a couple seconds to do, depending upon how fast your computer is. It might take more than a couple seconds, and you're going to be able to work with this data, and it's really, really cool. So I came across that, and I just wanted to share it with you. All right, so cool stuff. And now what I want to talk about are polar charts. Well, I'm really pushing my computer here. Basically, polar charts are going to display data radially, so around a circle. So what I want to do is I'm going to get wind data. So I'm going to say px and data and wind. And then what I'm going to do is go px and scatter polar. And I'm going to use that wind data. And the plot is going to use the wind data based on direction as well as frequency. So I'm going to say R is equal to frequency, and theta is going to be equal to the direction. The color is going to be based off of the wind strength, and the size is going to be based off of, again, the frequency. And then I'm also going to throw symbols on here that are going to represent the strength as well. And you can see there's the symbols and there's the colors and there's all this stuff. All right, so this is a polar chart which shows everything in a big giant huge circle. So it's really neat. It's somewhat distracting with the symbols on there. I just wanted to cover some different things though. Another thing that's interesting is you are going to be able to come in here and plot everything using lines, which sometimes work a little bit better because it just allows you to see your data more clearly because it gets a little bit busy here. And how you do that is with line polar, and I'm going to keep all of this stuff exactly the same, except I am going to get rid of these guys right here, keep it a little bit more simple, and I'm going to say that I want the lines to meet at the end, and I'm going to use a template here that looks better because it's darker, and Plotly Dark is the name of that template. It's just a coloring template, and run it, and there you can see is your same wind strength and direction data, and I think it looks a little bit nicer and it's a little bit easier to read. All right. So there is your polar plot, and now I'm going to show you a different way of comparing 3 different variables in a plot, and you do that with what is called a ternary plot. Okay, ternary plot. What I'm going to do here is I have a data frame that represents an experiment that was done on 3 people, 3 groups, and what I'm going to do is I'm going to plot out this information because it works really well. It basically just makes a big triangle and then plots everything. So px and scatter and ternary, and just use this data frame. And then I just point at my different things. There's 3 different parts that I want to latch onto. So there's experiment 1, and there's going to be experiment B and C. So let's go like this. Jump down here, paste that in there, and just change, well, go like this, go like that. Change this to B and C. B and C. Oh, and make sure you change this to experiment 2 and experiment 3, otherwise, you know, that's kind of pointless. Everything will be on top of each other. And let's go and change the hover name to group. And then let's change the color. There's gender data in it. That's where I'm getting these different things from, is just the data that is provided to me. And if I run it, you can see there's experiment 1, there is experiment 2, experiment 3, and you can see how these are all plotted together in this gigantic plot based off of, and coloring is based off of male and female. All right, so I'm trying to show you as many plots, useful plots as possible. And now I'm going to talk about facets, which are extremely useful. Okay, so you're going to be able to create numerous different subplots. So all on the screen, all at the same time, really quick. So I'm going to go and get our tip data, which you should be very used to seeing information about. And I'm going to go scatter, df, and tips. And x is going to be equal to the total bill. Y is going to be equal to the tip amount. And the color is going to be equal to smoker, and the facet column is going to be equal to sex, and I forgot my quote here again. All right, so you can see how all of this information, basically I'm plotting just the total bill for the male and female, and the colors are going to represent whether the person smokes or not. So there's 2 different plots, but I can get way crazier than this and do way more. So why don't we go and line up our data in rows and columns. So I'm going to go px and histogram, df, and tips. X is equal to total bill, and y I did that again. There's that. And Y is equal to the tip amount. And I want the color to be based off of the customer's sex. And I want facet row to be equal to the time. And what else am I going to do? I'm going to do another facet column is going to be based off of the day data and more. And then I'm going to also define category orders, and that is going to be based off of the day. And I am going to say that I want these to be in the order of Thursday and Friday, in quotes of course, Friday and Saturday and Sunday. This is extreme customization. And what else are we going to do? Let's also go and say that we want some time data. So I'm going to say time, and this is going to be based off of the lunch and dinner. That's the two types of times of day that we chart here, and run it, and you can see the created histograms that are stacked on top of each other, male and female, time, lunch, and the sum of the tip and the total bill, all in a really nice facet pattern. But let's go into another one. I'm going to load in a data frame that's going to contain like test information, and I'm going to show you how to do a facet plot using multiple. I'm using Seaborn dataset here. So I'm going to say load dataset, and I'm going to specifically grab this experiment that was done where they sort of distracted students, I guess, while they were trying to take a test, and then tested the performance based off of if they were distracted or not. All right, and I'm going to show you for every single subject that was tested. I just kind of think this is kind of neat. All right, so X is equal to, and solutions, and then I'm going to have the score that the student also made on our test, and then I'm going to do facets, and column is going to be based off of the subject being the student that we are testing. And then I'm going to wrap every 5 students. I'm going to go down to the next row, and to do that you say facets column and wrap is equal to 5, and I'm going to give this a title that is going to be scores based on attention. Scores based on attention. And then after I do all that, I can go figure and run it, and you can see scored based on attention, and each of the students, how well they scored based off of if they were able to have their full attention on the test at the time. All right, so cool stuff, and I saved the best for last because up next we're going to talk about animated plots. All right, so to create an animated plot, what I'm basically going to do with this is I'm going to create a scatter plot, and then what it's going to do is it's going to cycle through continent, GDP, as well as life expectancy changes by year. So I'm going to go and I'm going to get country data from something that's built into Plotly. So data, and this is Gapminder again, and there's Gapminder, and I'm going to say I want a scatter plot for all this information, and using my country data frame, and the x-axis is going to be GDP per capita, and the y is going to be based off of life expectancy. And then I'm going to say that I want this to be animated. So animation frame, and it's going to be animated based off of the changing years for our x's and y's that we just supplied. And the animation group is going to be based off of the country data and changes. I'm going to have the size changes be based off of the population, and the color is going to be based off of the continents, so that you will be able to tell where the different continents are. If you hover over the data, whoops, it's hover name, then it's going to give you country information. And this is going to be like, everything. I'm going to say that I want our log to be true. And I'm going to have a size maximum be equal to 55 and a range X between 100 and 100,000. So like this, 100 and 100,000. And then we'll do another range again. Let's go in the next line of one, and you'll see what this looks like. And range Y is going to be equal to 25 and 90, and run it. And whenever I run it, you can see right here is all of that data on all of the different continents. And here, life expectancy changes, GDP per capita. And if I could cycle through, and you're going to see all the changes as I cycle through, or I can hit play and it will show you all the changes right there on your screen. So really, really neat stuff. And hopefully you enjoyed that as well. And why don't I do just one more? I'm going to do a bar chart that is going to allow you to see population changes. So I'm going to say px and bar. This is the last one. I'm just going to do this really quick. X is equal to, and again, it's just going to be continent population changes. So Y is equal to population change. Color is going to be based on the continent. And next line, I'm going to animate it, of course. Animation frame is going to, and we're going to animate based off of the year. So we're going to get the population and continents for each of the years. Animation group is going to be based off of the country. That's how we are going to decide how this information is cordoned off. And I'm going to do a range, and we'll do range Y. This is just range X and Y is just showing the maximums. That's all it is. All right, so, and I'm going to say from 0 to a real big number. So 4 billion, something like that. That sounds good. And run it, and you can see our bar chart for all the different continents, and I can play this, and you can see how the bar charts change. All right, so really cool stuff, and Asia's getting pretty big. And I hope you guys enjoyed this tutorial series, and like always, please leave your questions and comments down below. Otherwise, till next time.